Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 4 of Text and Sentiment Analysis in R. The materials at the website below navigate to the regular expression section, and it should look something like this. So in this section we're going to take a little diversion away from sort of tidy text and talk about regular expressions. Now regular expressions are really helpful and useful because they enable you to search for patterns of text. Now when you're searching for specific words or specific phrases from a block of text, it's just generally relatively easy. You'll just filter on a specific word like hello. However, it can be much more complicated if you want to make this flexible. If you want to search for patterns, and regular expressions are a way of searching for patterns. So let's imagine here you wanted to try and find all of the titles and surnames within this block of text. I want to find all the surnames Johnson, James and Jackson, and all the titles Mr, Miss, Ms, Mrs, etc. Finding things like that becomes much more complicated because it's not finding something specific, it's finding something which fits into a pattern. Now fortunately, while searching and extracting text is a very complicated problem, it has been solved by computer scientists, and it's been adopted by pretty much all programming languages that I'm aware of, including R, and the solution that was created was regular expressions. Now regular expressions can look scary when you first see them, and you may have heard of them and thought, I'm not going to learn those, they look quite difficult. But once you understand the rules, they are actually quite simple, and they are so powerful that it really is worth sort of trying to get a handle of them. Now the syntax for regular expressions appeared and was first standardized pretty much in the Perl programming language, and now nearly all programming languages support what are called Perl compatible regular expressions, or PCRE. Now in R we use the strdetect function, which is from the stringer package, and we also use regex to then parse and sort of pass in regular expressions. So for example, we're going to start by sort of reading in Hamlet's soliloquy into a table. So I'm going to copy this into a new R Markdown notebook. So we're going to do new R notebook. Let's set the console down here as being a bit little. Do that. We're now going to save this, and I'm going to call this regex into my workshop folder. Okay, so first thing we're going to do is basically load up the tidyverse, which contains stringer, and we're going to read in Hamlet's soliloquy from this URL and create a tibble as we did before, where we have a line column, which is the line number from 1 to the length of lines, and then a text column which contains the lines itself. And indeed I'm just going to show you what that is, just so we can remind ourselves of that. There we are, here we have the soliloquy. Now we can use the strdetect function to filter out the lines that contain specific text. So for example, let us now just find all of the lines that contain the word to. So we take the text, we're going to pass it through the filter, because this is how we filter out lines, and we use the strdetect function to find all the lines in the text, in the text column, which match to. There we are, to be, to die, to sleep, to grunt. Those are the 5 lines that contain to, specifically with a capital T. Now we could do the opposite of this. We could filter out all of the lines that don't contain to by passing in negate as an additional option to strdetect. So we can go text, pass it through the filter. Filter is going to be a strdetect. We're detecting in the text column, we're looking for to, but now instead of finding the lines that contain to, we'll now negate this, and so it'll be all the lines which don't match. So these will be all of the other lines in the soliloquy. Oh, sorry, negate equals true. So negate equals false, well, not negated. What am I doing? There we are. There are these are the lines where it's been negated. Now at the moment, this is performing a case-sensitive search. We're basically looking for to, capital T. Now we can use regex to turn this into a case-insensitive search, so looking for to with a capital T for 2 or a small t for 2, or even a big O as well if you wanted a big O. And the way we do this is we actually put the regex into str_detect. So in this case we're going to now filter. Again, filter on a str_detect, but now we're going to filter through the text column, and instead of searching for 2 as we did before, we're now going to place the 2 into a regular expression, and we do that using regex, and then regex says we're going to look for 2 and we want to say ignore case. And make sure I close all of the brackets. There we are. And now when we search for this, we're getting as well the 2b here, but we also get the 2 suffer there and all of the other lines. Now regular expressions can do a lot more than just search for specific text. They can search for patterns of text. For example, what if we wanted to search for lines which contained the word the? We would want to exclude lines where the is part of a word, like there or whether. To do this, we were going to use a \b to represent a word boundary, such as a space or a new line. This means if we did \b the \b to search for word boundary followed by the followed by word boundary, that would find all of the occurrences of the word the. So let's now put that in. So again, we're going to do text, pass it through a filter on a str_detect in the text column. But now we need to do a \b for a word boundary to mean space, new line or something, followed by the word the, followed by a \b meaning a word boundary. Now, one thing about R is that in R, our backslashes have to be double backslashes because we have to do what's called escaping them. So when you're doing normal regular expressions, you may have seen one backslash if you've seen them before, but in R we use 2 of them because we have to escape the backslash. So in this case, double \b means a word boundary like a space or a new line, and so we're searching for a space or a new line, followed by a space or a new line. Let's run that, and now you can see we now have all of the lines containing the. There we are, the play, that is the question, the mind, the thousand, the rub, the respect, etc. But what if we now wanted to find all lines that contain the, where the is part of a word? Now in this case, instead of using \b, we could use \w, where \w means any letter. W is almost like word letter, which is what we use W. And so if we did this, let's go now, again, we're going to filter it. If I can type. Now we're looking from the text column. So we want the followed by a \w. Remember, we have to use 2 backslashes when we're in R. This would mean the followed by any letter. So now when we run this, we're getting whether. There's also a the in there anyway. But then we have them. There's no the in this line. There is just them. And then we've got theirs, rather, and others, and their. Now, what if we wanted all words which start with the, but are words that contain the? So in this case, we've got whether, and we just want the words that start with the, like their and theirs. In that case, what we can do is we can put a word boundary before the. So this would mean word boundary, space, new line, followed by the, followed by any letter. And there we are, we have them, theirs, their, and we don't have whether and rather and others. Now there are many, many special characters that you can use. And I'm just going to switch back over to this. We moved all the way through this part of the text. Here we are. So \w was any letter, \b was a word boundary, but you can use \d, which would match any digit, which is any number. So the \d would be the followed by a number. backslash s means specifically a space. So backslash b was any word boundary, but backslash s specifically means a space. As we said, backslash w was any word character, alphanumeric and underscore. So this includes, A to Z, 1 to 9 and an underscore. Backslash s, capital, means any non-white space. So anything that is not a space. Backslash d is anything that's not a digit, so anything that's not a number. Dot means any character, so match anything. Backslash t is match a tab, and backslash n means match a new line. Now, instead of using backslash w to mean any letter, and remember that includes alphanumerics as well, you could also ask to match specific letters. So for example, by using square brackets, we can actually say one or another letter. So square bracket AIY would mean an A, an I, or a Y, and thus TH square bracket AIY would mean a T and an H followed by an A, an I, or a Y. So let's try that. So I'm actually going to put this in here, so I don't have to keep typing this all out. So we're going to do a TH followed by an A, an I, or a Y. If we now run that, so I did THE followed by an AI or a Y, and actually there we are, there's there. That's the only word where we have THE followed by an I. Let's do a TH followed by an AIY. And now we have this, so we have things like thy, THY, we have there, THI, we have, let's see if we can find a THA, one of these, that, there's a THA. Now we can control which character is matched using the square brackets. So as I said, AIY would be match A or I or Y, but if I wanted to match anything from A to Z, I could write A-Z, so that would match anything from little a to little z. If I wanted to do this capital, I could do matching anything from big A to big Z. And if I wanted to match any character from little a to little z and big A to big Z, it would be AZ, like that. Now you can also match digits. So 0 to 9 would be match any digit from 0 to 9. But equally, we could do specific digits like 0 to 2, 4, 6, 8. That would be TH followed by any even number. And then we also have something which is a caret. So this symbol here is a caret, and that means not. So that would mean not the digits 0 to 9. So if I wanted to, I could say not A or I. So TH followed by something which is not an A or an I. And so we'll get things like this TH is fine. So let's say not THAIE. So remove some of them. I think I might need to actually put the caret before all of them. There we are. Let's try that. I'm interested why that one has come in. Maybe I've got something I've not quite understood. But generally caret means not. And we can also use repetition. So repetition in the matching means we can repeat things several times. So again, flipping over to the notes here. If you use star, that means match it 0 or more times. So \w star means match 0 or more letter characters. Plus means match 1 or more times. So \w plus would mean 1 or more word characters. Question mark means match 0 or 1 times. So \w question mark would mean match 0 or 1 word characters. And then by using curly brackets, we can actually specify the number. So \w3 would mean match this any word character 3 times. N comma would mean at least 5 times in this case. So \w curly brackets 5 comma means match a normal character at least 5 times. And then mn means match it between that range. So in this case, between 5 and 7, where we match any word that's between 5 and 7 characters long. And of course, we could use this here. Let's try and find all words all lines which contain words that have at least 10 to 12 characters in length. So that's a \w for any word character, and then 10 to 12 would mean it must be 10, 11 or 12 word characters long. So here we've got remembered, enterprise, resolution, conscience, undiscovered, consummation, etc. Indeed, let's try and even do 11 to 12 characters long. There we just have these lines here which have the 11 or 12 characters long in the line. Now you can do this with sequences of characters as well by putting them into round brackets. So I particularly find this useful when I'm using this with a pipe, which means an or. So let's say I want to find all lines which contain the words monologue or dream. So if I put in here in round brackets monologue, that would give me all lines that contain the word monologue, as we have here. But if I now want to say all lines which contain the word monologue or dream, it would be like this. We're using the or. This pipe character means or, so this would be now monologue or dream. And there we are, we have the lines containing monologue or dream. Now we can combine this sort of like round brackets with the pipe or character to really play with some modifiers. So let's now say I'm going to do this. I'm now going to do a str detect on text. And in this case, I'm going to do a word boundary. So it must be a word boundary. Then we're going to start off with a capital T or a small t, and then an H and an E, and then RE question mark followed by a word boundary. And what this means is it must be a word boundary followed by a big or a small t, followed by an H or an E, followed by 0 or 1 REs. So this would match the or there with a small or a big T, followed by a word boundary. And there we are, we now have things from the with capital, the, and another capital there. Then we have a theirs, there, because they take the apostrophe as being a word boundary. There's the, we have a the in this line, the in this line, the in that line as well. So this is basically enabling us to match the with a capital T, the with a small t, there with a capital T, or there with a small t. Now you can also specify that this match must be made at the beginning of the line, and we do that with caret, which we also used as a not before, but that's how things work. So if we do this, it means we must match the at the beginning of the line. So these are all of the lines that begin with the. Now we can also match at the end of the line by using $. And so if you put the $ at the end, this would mean all lines that end with on. Consummation and resolution. Now, as I said, regular expressions are very powerful. We've sort of done a quick run through a lot of them here, but we've sort of scratched the surface. There is a really good cheat sheet which is part of Stringer, and also a very nice description available here. It's kind of like you kind of learn them, and then you can use cheat sheets to kind of remember things from them. So just to show you the cheat sheet. There we are, you can see all of the different ways of detecting matches, and this has all of the backslashes that you need, and the ors and quantifiers that we talked about before, and then grouping. So once you've learned it, it's actually really powerful. Okay, now as well as matching text, you can also use str replace to replace text, and this is useful for then modifying texts. So let's go back to this. Let's now go on to a new R block. So the pattern, the way that you use this, is basically would be a str replace where the first argument is the thing being searched for, the line of text, and then the second argument is the pattern that you're going to search for, and then the third argument is the thing you're replacing the match with. So let's now take a line of text. So I'm going to take a line 4-2. Just to show you what line is. The reason it's 4-2 is because this is line 4, the fourth row, and then the second column, because we're taking the text here. So this is now just a standard line of text. If we now use str replace on this text, again if I can type, we place in the line of text that's going to be sort of searched and replaced, and let's now replace everywhere where we see banana, B, with the word banana. So that's now changed it from to be or not to be, that is the question, to banana or not to be, that is the question. Now notice this has only replaced the first match that it's found. So the first B has become banana, but the second B has been left alone. Now if you want to replace everything, we can use that with the function str replace all. There we are, to banana or not to banana, that is the question. Now you can also choose to match the string using a regex. So for example, here we could put in regex, and now we're going to match to be, but case insensitively. And that means we can now, let's replace that with ice cream. Ice cream or not ice cream, that is the question. And because we've used a regex with ignore case, it's matched the to be beginning with a capital T and also the to be here beginning with a small t, and it's replaced both of those with ice cream. Hence why we have ice cream or not ice cream, that is the question. Now if you want to apply this this replacement to all lines in a tibble, then we have to use the mutate function like we do when we're working with all tibbles. And so let's now create a line here. So let's say I'm going to now take my entire block of text, the entire soliloquy. I need to pass this through the mutate function, where now the text column is going to be equal to str replace all of the text column. And let's now just change all of the B's into bananas. There we are, to banana or not to banana, that is the question. Do we have any more bananas in this? For who would banana are the whips and scorns of time, etc. And makes us rather banana are these ills we have. Who would finals banana are? Because we replaced all the B's, and of course B-A-R, because it was bear, becomes banana R. Cool. Now of course, because this has replaced all of the T8, all the B's with banana, let's now do something a bit more clever. So this is doing B on its own. Let's replace now all of the words the. So this is word boundary, followed by the, followed by word boundary, and we'll ignore case. So let's do that. Let's do word boundary, so that's \b, followed by the, followed by word boundary. But we want to make sure we ignore case because we want capital D's and not capital T's. So we can put this in a regex. Ignore case equals true. Let's sort of make this over go in multiple lines. There we are. Make it look prettier. And if we now run this, to be or not to be, that is banana question, whether it is noble in banana mind to suffer banana slings and arrows or arranger's fortune, or to take arms against a sea of troubles and by opposing them to die to sleep. No more, and by sleep we say banana heartache and banana thousand natural shocks. So you can have fun with them. Now what I would say is regular expressions are really powerful. Once you get them, they become almost like second nature if you use them for a while, and it's just so super useful when you're trying to sort of look for patterns. It's much better than trying to filter on one word, then filter on another word, then filter on another word. A regular expression sort of collapses all of that down. But while they are very powerful, and you can use them to search for specific output from your programs and do really powerful text manipulation, they are a little bit right-only. If you don't know what regular expressions are, they can look intimidating. So when somebody sees this, they're like, what on earth is that? And particularly the ones a bit further up where we were sort of using this. That, to someone who doesn't know what a regular expression looks like, is really intimidating. And so what I would say is do add some commenting into your code so that your future self, but also other people who don't have regular expressions can understand what this is doing. Always comment them, explain in English exactly what you intended to mean when you wrote them. And, that way you kind of make it a bit safe. As I've said, once you've memorized the rules, you'll find regular expressions to be very easy to read and very easy to use and just massively powerful. I use them in so many different programs, but without comments, they will be a little unintelligible to everyone else who looks at or relies on your code. So this brings us down to the exercise, and I want you to find all the words that follow the, so not the word the, I want everything that follows the in Hamlet's soliloquy, and replace the words that follow the with the word banana. So it should be to be or not to be, that is the banana, rather than that is banana question. So press pause, have a go at this, and when you come back from pause, I will show you an answer. Okay, you've come back from pause now. Again, this is just an answer. It does not necessarily mean it is the answer. So I've already loaded up. Let's go from here. Hopefully you've done the same thing. You've already loaded the text up into a tibble. So let's now see how we can do this. Well, we want to replace all of the words that follow the. So the first thing to do is actually find them. So if I wanted to sort of find those words or the lines that follow the, I would be using regular expressions. So let's put this into the mutate first. So we'll do text equals str replace all. But now, how do we find the words that follow the? Well, first, how would we find the word the? Well, the word the will be a text boundary, followed by the, followed by something. Now I want the space something, so I'm specifically going to search for word boundary followed by the, followed by space, which is \s. Now the word that follows the will be something which is some characters. So it will be any character, which is a W, and one or more of them. So this would mean a word boundary followed by the, followed by a space, followed by one or more other words, other characters. So that would be the something. Now if I want to replace the something, what do I want to replace it by? Well, I want to replace it by the banana. So notice that I'm not trying to take out this word and separate it from the. I'm actually just saying, well, let's replace anything which is the something with the banana, because that makes my life easier. So let's see, does that work? Okay, we've got to be or not to be, that is the banana. Whether it is nobler in the banana to suffer the slings and arrows of a ranger's fortune. But haha, I said all words after the, well, we have the slings, that should be the banana. So what we actually see we need to do is actually pass this through two mutates. Indeed, actually, I could do this two ways. I could have said match T or T, like that, which I think would work. There we are, the banana. But the problem with doing this is it's replaced the small t here, the big T with a small t. So that's not going to be quite what I want. Instead, what I need to do is pass this through a second mutate, because I'm really using a second thing to replace it by. Where now what I'm doing is I'm not looking for the banana with small t, I'm looking for the banana with a big T. And now I can replace this with the banana like that. I think this is probably an easier solution than trying to dynamically change the case of this beginning T here. I'm sure there's a way of doing it, but I think this is easier just putting this through two mutates, one after another. And there we are. To be or not to be, that is the banana, whether it is nobler in the banana to suffer the banana and arrows of ranger's fortune, or to take up arms against the sea of troubles and bows and end them, to die to sleep no more, and by a sleep we send the banana and the banana natural shocks, etc. So that's the answer to this exercise. That's now brought us to the end of this section of the workshop. I hope you enjoyed it, and I look forward to seeing you in the next section.